concepts of similarity of two triangles. When we can show two triangles similar, which are the required criteria for similarity? So let us continue and study about actual criteria for showing two triangles congruent. Now here you can see, if we think about any two triangles, for example, if we think about triangle ABC and triangle DEF, you can see here triangle ABC is little bit bigger and triangle DEF is smaller. But if you see the similar markings, angle D single curve, angle A single curve, angle B double curve, angle E double curve, angle C triple, and angle F triple. It shows that three angles of triangle ABC are congruent to other three angles of triangle DEF. Okay, and if the ratio between the corresponding sides of these two triangles, corresponding sides of these two triangles is also equal, see here, AB upon DE is equal to BC upon EF is equal to CA upon FD, then the two triangles are similar. So these two things means angle should be congruent and side should be in proportion, are necessary for showing two triangles similar. Now let us see one criteria. Now before that, first if we do the construction, before that, I think you know or don't know how to write the two triangles similar with the help of sign. You can see here symbol for showing similar triangle is this. So how to read this? Triangle ABC is similar to triangle DEF, and before that you know the sign for congruency was like this. Sign for congruency was like this. One more time I'll draw here like this, and now sign for similarity is like this. So this was about the sign. Now let us see if we consider these two triangles. Which two triangles? ABC and DEF. What is given? What particular information is given regarding these two triangles? Angle B 60 degree, angle E 60 degree, angle C 40 degree, angle F 40 degree. Okay, and now these two triangles are drawn based on these questions. Here, what is the activity? Not question. Draw two angles. See here. Draw two lines, not angle, segments BC and EF of two different lengths, say 3 cm and 5 cm respectively. Then at the point B and C respectively, construct angles PBC and QCB of some measures 60 degree and 40 degree, means at point B and point C. Also at the point E and EF, construct angles REF and SFE of 60 degree and 40 degree respectively. So according to that, the figure is drawn. Okay. Now what we have to do here? See here. One minute, this page has gone here. Now as per the given condition, figure is drawn. Now what they wanted to see here, see BP and CQ intersect each other at A, and ray ER and AFS intersect each other at D. So in the two triangles ABC and DEF, you can see that angle B is equal to angle E, angle C is equal to angle EF, and angle A is equal to angle D. That is, corresponding angles of these two triangles are equal. So here, what can you say about the corresponding sides? So if we'll see BC upon EF, that measurement are given 3 upon 5. But what about AB upon DE and CA upon FD? These two information means this and this not given. Okay. Now if you measure all those, then you will get that that is also equal to same. Okay. But here that information was not given. It means based on that you will find that their corresponding sides are in the same ratio or proportion. So we will conclude on one criteria of similarity of two triangles. What is that criteria? Let us see here. If in two triangles the corresponding angles are equal, then their corresponding sides are in the same ratio or proportional, and hence the two triangles are similar. It means if the information regarding three corresponding angle is given, if three angles of one triangle are congruent to three respective or corresponding angles of other triangles, then based on that you can say that their ratio of ratio of the corresponding sides will be also same, and based on that you can say that triangles are similar. So this was our first test of criteria. That criteria is referred as AAA, angle criteria of similarity of triangles. Now here you can see how they have proved this criteria. Here they have considered two triangles ABC and DEF. Then they did one construction, means they cut DP in such a way that DP is equal to AB, means they have drawn, in other words I can say DP is equal to AB and DQ is equal to AC. See here, DP is equal to AB and AC is equal to PQ. So similar marking we can give like this. Okay, and they joined PQ. Now see here, this theorem can be proved by taking two triangles ABC and DEF such that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle EF. Cut or construct DP is equal to AB and DQ is equal to AC and join PQ. Now if you think about these two triangles ABC and DPQ, AB is congruent to DP or equal, AC is equal to PQ, and angle A and D that also already given. So which test happen here? I am asking you about triangles test of congruency. So yes, happen here. So triangle ABC is congruent to triangle DPQ by which test? Yes. Now, so angle B will be automatically equal to P. Because these two triangles we have shown, and first given that angle B is congruent to angle E also. So B is congruent to P, is congruent to E. So if P is congruent to E, see here, if P is congruent to E, then PQ will be parallel to EF. PQ will be parallel to EF. So see here, and if PQ will be parallel to EF. Now how I told here, angle P is congruent to angle E, because B is given congruent to E, and we have proved B is equal to angle P. How? See here, again I am repeating here, angle B is congruent to angle P, that is given, and first it was given angle B is equal to angle E, that's why we could prove P is equal to E. But if we consider side PQ and side EF, for these two sides angle P and angle E are corresponding angles. See, angle P and angle E are corresponding angles. So if two corresponding angles are congruent, then concerned lines are parallel. So you can say PQ is parallel to EF, corresponding angle test. Therefore, then you can say dP upon PE according to basic proportionality theorem. Here you can say with the help of BPT. With the help of BPT, you can say these two triangles are, the sides are in proportion. dP upon PE is equal to dQ upon QF. Now AB upon DE, see here, AB upon DE is equal to AC upon DF. Is it possible? AB upon DE is equal to AC upon DF. Is it possible? Tell me. How? Because we have proved no. What? ABC is congruent to DEF, and what we are saying here, AB upon DE is equal to AC upon DF, because corresponding sides are congruent, so their ratio will be equal. Now AB upon D already we have taken, and that will be equal to BC upon EF, and that is automatically equal to AC upon DF. So here AB upon D is also equal to BC upon EF, also AB upon, so that AB upon D is equal to BC upon EF is equal to AC upon DF. So in this way we could prove this AAA test of similarity. Now you know that for if we consider any two triangles, and for those two triangles two pairs are congruent, so automatically remaining third will be congruent. So every time no need of showing all three angles congruent. If only two pair you will show congruent, so based on that you can show two triangles similar. So if two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property of a triangle their third angles will also be equal. Therefore AAA similarity criteria can also be stated as follows, that is AA test. See here, I am reading now AA test in front of you. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. Means here we have learned two tests. Which two tests we have learned? First one is A, and based on that, in short we can say AA. Means every time no need of showing all three corresponding pairs of angles, only any two pairs you can show what? Congruent. Okay, in this way we could prove this. Now see next example. Now what is given here? They have asked you draw two triangles ABC and DEF such that AB is equal to 3, BC is equal to 6, CA is equal to 8. See here, like this angle which having means triangle, in triangle ABC, AB is 3 centimeter. In figure you can see BC is 6 centimeter, AC is 8 centimeter. Here D is 4.5, here EF is 9 and DF is 12 centimeter. Now you can see here, in last example we had seen, we had shown three angles congruent. Now here in this figure we will show three, means corresponding sides are in equal ratio. See here, AB upon DE, you check, AB 3 upon 4.5, that is 15 to the and 15 3 the means 2 upon 3. So same way 8 upon 12, that is 4 to the 4th, means all ratios are equal 2 upon 3. So, and if we measure angle A, B, C, D, E, F, you will see that all the corresponding angles are congruent. Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Okay, see, like this you will check this. Here A is congruent to D. Okay, then B is congruent to E, and then C is congruent to F. You will get that. So another test we have got here. Which test? Here, if in two triangles sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal, hence the two triangles are similar. So this test is called SSS, that is side similarity criteria for two triangles. So you can prove this theorem by taking two triangles ABC and DEF such that corresponding ratio is equal, that should be less than 1. Okay, like this. Here they have shown, that is triangle ABC and triangle DEF, where sides sides are in equal ratio, and then we can show the two triangles similar with the help of which test? Yes. Okay, now here see what is a remark is important. What remark they have given? Either of the two conditions, namely corresponding angles are equal or corresponding sides are in same ratio, is not sufficient for two polygons to be similar. However, on the basis of theorem 6.3 and 6.4, you can now say that in the case of similarity of two triangles, it is not necessary to check both the conditions, as one condition implies the other. That I already told you. Okay, now 1 minute, again page has gone. We were on this page, no? On which page we were? This already over this. Now if one angle of a triangle is equal to one angle of the other triangle and the sides including means it is next test. So we'll see that test directly. See, according to name SAS, you can see there side angle side, but what is the condition of that angle in between two sides? See here, if we consider AB AC, between AB and AC there should be angle A, and between here PE and EF there should be angle D. So now you can consider, that is AB upon DP is equal to AC upon DQ, sorry, AB upon DE. is equal to AC upon DF, and angle A is congruent to angle D. So based on SAS similarity test, means for SAS similarity test you need two corresponding sides ratio same and the angle between those two corresponding sides, that should be congruent. So we'll skip this example, only you have to keep the notes, test in your mind. Based on that, examples may be asked. Now let us see some examples. See, first observe these two triangles POQ and ROS. What is the question? In figure, if PQ is parallel to RES, prove that triangle POQ is similar triangle SOR. Only PQ is parallel to RS, this information is given. Now you know that if two lines are parallel, then their corresponding angles are congruent, alternate angles are congruent. So we can see this. What is given? PQ, see here. PQ is RS, that is given. So angle P is equal to angle S. See, this angle P and this angle S is congruent. Why? Alternate angle. Similarly, angle Q and angle R, these angles are also congruent. How? What is the reason? Alternate angles. And if you see this angle POQ and angle SOR, they are also congruent according to vertically opposite angles. So just we have studied what? If three angles of one triangle are congruent to three corresponding angles of other triangle, then two triangles are similar. So triangle POQ is similar triangle SOR, AAA similarity criteria. So in that way, what is our target? We have to show that only POQ is similar to triangle SOR. Okay. Now one more triangle, one more figure they have given here. How pages are going, I don't understand. So here you can see that no theorem that is over. Example we were saying. You can see this example. You have to observe this figure. Triangle ABC and triangle PQR. In that if you observe this 6 upon 12, 1 upon 2 means BC upon PQ. Then AC upon RQ 3 root 3 upon 7, AB up, you can see AB upon RQ, that is 3.8 upon 7.6, that is 1 upon 2. Okay. 1 minute, pages has gone. Page number 6.45, how direct came. Here and 6 upon 12, that is at 3 root 3 upon 6 root 3, 1 upon 2 means the ratio of all three corresponding sides is equal, and angle, therefore they have asked you angle P. So based on that SSS test you can show these two triangles are similar, and then angle A is equal to angle corresponding angles you have to show. So AB, see here triangle ABC similar triangle RQP. So angle C is equal to angle P. So angle C is equal to angle P. So two angles are given. So those two angles 80 and 60 will add, and from 180 we can subtract. We will get angle P, that is 40 degree. See here. In triangle ABC, angle A is given 80, angle B is given 60. So first we have to find out angle C, because according to correspondence C is congruent to P. So from 180 if we will subtract this 140, we will get 40 only. So angle P will be 40 degree. See here, angle P is 40 degrees. In this way you can solve the examples. Regarding remaining examples, we will learn afterwards. Till that we'll stop here. If any doubt you can ask me. You are